Welcome back. Today we're going to go over factoring by grouping. So there are two major ways that we're going to factor this week. If we factor by grouping, we're going to be looking at polynomials with 4 terms. Now next week, we're going to use the sum product, which I also say the X method. Just put an X here. And we'll use that method when we have 3 terms, or quadratic. Okay, now the steps for factoring by grouping. So for factoring by grouping, the first thing we need to do is group the terms. So we're going to group the terms, and most often than not, it'll be into pairs. So we're going to first look at the 2 first terms, and we're going to factor the GCF from the binomial. And those are going to be the first 2 terms, if I could write that in there. And then we're going to factor the GCF from the last 2. Now, what we want to do at the end is factor out whatever the common binomial will be. And remember, binomial has 2 terms, right? It's usually like x plus 5, 2x plus 1, something like that. All right, so factor by grouping. We have 4 terms here. We have x cubed and negative 5x squared. That'll be our first pair. And then we have 3x minus 5. So we're going to look at the first 2 terms, and they both have a GCF of x squared. So when I take an x squared from x cubed, I'm left with x, because x squared times x brings us back to x cubed. If I divide 5x squared by x squared, I'll be left with 5, or minus 5. Remember, I had that negative out in front. Now let's look at the next 2 terms. And you can see that 3x and 15 have a common factor of 3, of positive 3. So that's why I wrote a plus 3. 3x divided by 3 leaves us only with an x, right? 3 times x brings us back to 3x. And then negative 15 or minus 15 divided by 3 is going to be minus 5. So we just did our steps 1, 2, and 3. And you can see that there's going to be a common binomial, x minus 5. So we can factor out the x minus 5. So we have x minus 5 and x squared plus 3. That's all we can do, all right? None of those factor anymore. Now let's consider example 2. If we look at the first 2 terms, the GCF of 3x cubed and negative 6x squared will be 3x squared. So when I divide 3x cubed by 3x squared, we'll be left with an x, and then we'll be left with minus 2. Now looking at the next 2 terms, well, 15 can come out of 15x and negative 30. So I'm going to factor plus 15, and we'll be left with x minus 2. Now we can see that we have the same factor, same binomial factor. So this will end up factoring to 3x squared plus 15, because that's what would be left if we factor out an x minus 2. Now I didn't see this before, and I need to make sure I'm careful too. There was a GCF that we could have factored out, and you can actually see it here in this binomial, right? So we have this 3 that could come out of both terms. So I need to make sure if it's in completely factored form that I factor out the 3. And so I'm left with x squared plus 5 and x minus 2. Now, when we multiply everything back out, FOIL, we should get back to this polynomial, right? But I want to make sure that all of my factors are prime. Now let's go to example 3. For example 3, again, we're looking at the first two terms. And 2 and 3 don't share any common factors except for 1, but we can factor out an x squared. And when I factor out x squared, I'll have 2x minus 3. Now for the next two, I can factor out a negative 3. Because I want to have a positive 2x in there, minus 3. Right? We want that binomial to be the same. So when I factor out 2x minus 3, I'll be left with x squared minus 3 times at 2x minus 3. And that's prime. Okay, both of those are as factored as much as we could. All right, for the last one, let's look at the first two terms. We have 4k squared. So we'll be left with a k minus 3. And looking at the next two terms, well, we could take out a negative 5. And when we factor that out, we have k minus 3. So this is going to factor into k squared, 4k squared minus 5 times k minus 3. Just remember, this parentheses, this factor over here, is always going to be what we could say is the leftovers. Whatever you get when you factor out k minus 3 from each of those terms.